Hello, my name is Walker Mitchell, and I am a product marketer here at Semiconductor. Thank you for joining me for this introduction to the eFuse product family. In this video, we will quickly discuss what an eFuse is, what the key applications are, and our current product offering. There are a few key challenges when trying to implement overcurrent protection in modern systems. The first challenge is guaranteeing the SOA, or safe operating area, of the end application. In order to guarantee the SOA, you need to protect against overvoltage, overcurrent, inrush current, overtemperature, ESD surge protection, and in many cases, reverse polarity protection. Guaranteeing SOA is good, but an increasing number of end markets also require conformance to various functional safety standards. In order to achieve this, you will need advanced diagnostic features, fast response, safe state restoration, and low failure in time rate. Finally, while addressing the first two challenges, you need to maintain energy efficiency through low quiescent current, isolating faulted lines, and also indirectly save energy by reducing wiring. Traditional fuses cannot meet all these requirements, and that is where eFuses come in. So, what is an eFuse? An eFuse is not just an overcurrent protection solution, it also solves your thermal and overvoltage protection requirements, as well as short-to-ground and short-to-battery protection. In some cases, such as solid-state drives, reverse current blocking is also required to prevent large capacitors from bleeding charge upstream during a shutdown event. eFuses also help system designers achieve functional safety requirements through some of the more advanced features shown in this diagram. The real-time current monitor can be used a couple of different ways. One way being to implement a power limit feature where you want to measure both load voltage and current and shut down if a certain threshold is reached. Another way to implement this current sense would be for load diagnostics and debugging. The power good feature is valuable to applications in which power sequencing is required, where certain power rails in a circuit are not turned on until another rail is powered up and stable. How does an eFuse work? Looking at the block diagram in the middle of this slide, you can see that the critical path from VCC to the load is simply a power FET driven by a charge pump. A current limit block is there to monitor the amount of current running through the load and shut down once the programmed limit is reached. The thermal shutdown block functions similarly, but instead measures the FET's junction temperature and shuts the device down if it reaches unsafe levels. Additional important blocks include the DVDT control that allows you to set the inrush current, the UVLO that shuts down the output if the input droops too low, and the enable fault block, which can be used to check the eFuse for load fault conditions and reset the device. Another cool feature of eFuses that expands upon its already rich feature set is that they can be placed in parallel to achieve higher load currents. How is this done? It's done using the tri-state enable fault pin, the functionality of which is shown on the left. Basically, when the eFuse is tripped, this pin is pulled down to that intermediate voltage level, and if multiple eFuses have their enable fault pins tied together, they will all shut down. The enable fault pin has a fan out of 3, meaning that up to 4 eFuses can be tied together and act as one. This type of architecture is popular in higher current applications such as hot pluggable fans, common in the cloud computing industry. What are the applications for an eFuse? There are many applications for eFuse, but we will focus on a few of the most popular ones in this video. First, we will discuss the cloud applications. In this diagram, you can see 4 different sockets for eFuse. The server and storage rack diagrams both demonstrate the so-called dual fuse architecture, where there is a single main high current fuse and a multitude of other low current auxiliary fuses. This main fuse is usually in the range of 50 to 60 amps and is either implemented as a discrete FET with a hot swap controller or an integrated solution such as the NCP 81295 50 amp eFuse from Semiconductor. The auxiliary fuses in the diagram can be anywhere from 3 to 10 amps and are used like this. When the main fuse trips, the auxiliary fuses allow the server's key elements to remain powered up in order to run some diagnostics before you completely shut down the whole system. Fans are also hot pluggable in server racks, as they will need replacing every so often, and you do not want to power down the whole system just to replace a fan. So naturally, it requires an eFuse as well. Finally, on the right-hand side, you will see the hot pluggable SSDs and HDDs that require eFuses for inrush current protection, as well as reverse current blocking for safe shutdown. Not only do the memory devices require eFuses, but the backplane requires protection from a bad drive being hot plugged into it. Okay, moving on to other key applications. eFuses are also required in RAID and storage systems as seen in the upper left. SSDs have additional needs for protection when it comes to DC-DC converter as shown here. Also, we show e-scooters and e-bikes where they are used for different applications like the motor, lighting, and other auxiliary loads. Then there's 5G and telecom applications where you want to protect all the various RFPAs, which are ever increasing in number as we move into massive MIMO communication. Moving on to industrial. In a typical industrial automation application, an eFuse is required on the main 24-volt rail, as well as on all the analog and digital I/Os. Similarly, you can use eFuses to protect DC motors in the case of power tools and industrial drones. Finally, you can see eFuses used as replacements for DC relays plus the fuse that protects them for turning on and off loads. You can quickly see the benefit of the eFuse in this application by looking at the waveforms in the bottom right. The top curve shows a typical DC relay turning on a solenoid valve. You see all that chattering noise? That is not ideal and is electrically stressing on the system. If you look at the waveform on the bottom, that is an eFuse being used to turn on a solenoid. The controlled slew rate of the eFuse is much cleaner and will lead to longer lifetime of all the components. Quickly looking at some automotive applications, you can see here that eFuses can serve inside of ADAS domain controller, heads-up displays, telematics, and harness protection. What is the current offering of eFuse devices? We have a wide variety of devices available across voltage ranges and current levels. Looking at this chart, the y-axis shows the current handling capability, and the x-axis shows the complexity of the features. You'll see that our legacy products on the left-hand side had the standard feature set with lower current handling capability, and as we have built up the business, we have started releasing higher current devices as well as more complex devices. Looking at NIS 5135, one of our legacy products, it has the classic feature set of DVDT, overcurrent protection, overvoltage protection, overtemperature, and enable fault, whereas looking at our recently released NIS 6350 and the soon to come out NIS 6432, these have enable fault, digital enable, reverse block, and IMON iSense, as well as all the other features. Looking at our 12 to 24 volt devices, same chart, x-axis is complexity, y-axis is current. Our legacy products reside in the lower current, standard feature set, and we are continually adding more and more eFuses with diverse feature sets and higher current handling. Looking at this chart, we're seeing the NIS 5232 and 5132, which are the legacy devices. And then recently this year, we released the NIS 5020 and NIS 5021, which are footprint compatible, pin-to-pin compatible, and are higher current handling. Soon to come out are the NIS 5420, NIS 4461, and NIS 6420. Same current level as the legacy products, but with more features such as IMON iSense, and then reverse current blocking in the case of 6420. If you would like more information on eFuse, please visit www.onsemi.com and type in eFuse in the search bar. Thanks for watching.